All right, so we have a means of representing a script, right? That of two actors. In this case, a human actor and then the system. This would be a great way of representing perhaps a particular use case, right? Of a user interacting with the system and taking turns. And we're representing as a collection of various interactions and an input interaction and an output interaction. And the controller would be the responsible for running through this script, right? And then a test harness can take this script, right, and compare it against what we would expect the behavior to be. Right? So, for instance, a controller might or a test harness can take this a collection of interactions, iterate over each one, right, and grab each one of these interactions and do what with it, right? Right now we don't have any actions that any one of these interactions can do, right? The only thing that we have is this the constructor, right? The constructor just takes it and then just copies these into a stream. So we'll use a generic apply like a run, right? Do something with the stream with the input and output. Right now, the only thing we're going to do is that we're going to do something simple. We're just going to concatenate the values as they come in, right, into a particular stream, an input-output stream, and we're going to concatenate all these dialogues, right? That 3 plus 4 is indeed 7, and then followed by 5 plus 7 is 12, and this is going to create a long concatenated string. And then we're going to be able to compare it against the expected string, right? If they're equal, then everything went correctly, right? That is the expected behavior that we were expecting, right? We're going to compare the actual concatenation of all these strings together, right? The 3 plus 4 equals 7, and then concatenate it alongside with 5 plus 7 equals 12. Concatenate the whole thing, and then we're going to compare against the expected results. So that's we're going to keep that simple implementation of what each interaction does, right? It's we're going to have it apply whatever the script is. In this case, again, we're going to have something simple. We're going to pass in two string builders that are going to allow to keep track of the ongoing conversation. If it's an input. If this is an input interaction, typically I'm just going to take the input builder string, right? I'm going to keep it and copy it into my local string, into my local stream, and then it'll be used for concatenating all these inputs, right, into the streams. If it's a print. I'll use the output, right, to be and concatenate into the output what the outputs of those interactions are going to be, right? So notice that we have declared this generic apply. We don't really know what that means just yet, but since it's being implemented, since it's being called on both interactions, both the input and the print, both have to implement that same function. Right, so we declare the apply signature on the top level interface. Notice that before we didn't have a body, right? We was just some amorphous interface, right? So there's the apply signature, and then both implementations need to implement this apply, right? And again, the simple implementation is just going to be that to copy the string builders and the input and output builders into a local variable. So for instance. The input interaction is just going to take the int, right? Whatever the string builder is, every time it iterates, right, over each one of the interactions, it's just going to append, right? It's just going to append, 3 plus 4, 5 plus 7. It'll just keep appending as the dialogue keeps going. We can then take that resulting string and convert it back into a simple string and then compare. Is this what you were expecting? Yes. Yes. Yeah. Right. Exactly. Yeah. It makes it also easier to read for human consumption, right? That you can see the entire dialogue going through. Right. and it's going to have the based on the last control that we looked at, the bad controller that we were trying to identify, and the way we got around that, it was to use the original values, the 3, the 4s, the 2, the 7s, whatever, right, as part of a resulting string, so that we would catch the fact that perhaps the controller might have munged or done some weird transformation to the data, right? This would catch it. Same thing for the print, right? It's but just slightly more elaborate, right? It's not just one string. It could be multiple strings, but what's other than that is identical to the input. What one is representing what the user might type in at the keyboard, whereas this one is representing what the model is going to write as an output, right? And we're going to pass these two to the controllers, the same exact controllers we had earlier, right? And the inputs are going to be what the model takes as the two values that we're adding or multiplying or dividing, and the resulting are going to be written to this print interaction. Okay, so now we could perhaps write a test run that could take as argument the first argument, perhaps the model that we want to test, right? And perhaps we can take the model that just does a simple add and returns a simple integer value, right? Or we could take the other one that is a little more elaborate, that takes the original inputs in the number 1, number 2, adds them. Right, and what that results, converts it into a string that you have the actual interaction. The 3 plus 4 equals 7. Right, that allows us to verify that the original 3 that I passed, the original 4 that I passed, was not misinterpreted anywhere. Right, that what I sent in, it's the same output that went in. Right, right. So the controller can internally, use the streams to pass this to a model, and the model can then operate on this and come back with the resulting 7. And then the test run would build the expected interaction, based on some fake input that we're passing. The 3, the 4, the 5, the 7s, and whatnot. All those are fake, right? These are not typed at the keyboard. That we would pass in that fake input, and also build the expected output. Out of those, notice that this is the output, right? It was going to append the 7, the 12, the expected results of each one of those interactions, and this is going to append the plus 3, 4, plus 5, 7, and whatnot, all the inputs of those interactions, right? So this is the expected is going to be compared. It's going to be compared as we pass all these fake inputs into the controller, right? The model is going to operate on them, and it's going to result on the 7, on the 12, or on whatnot. Yes.
Where's this test running going to be made?
Oh, it would be a JUnit, right? It would be at test.
Oh, this is in because the last one was you making the actual fake test.
Yeah.
And then this is like.
No, this is hashed out. This is the whole thing. It's a continuation. ... It's continuing here. Yeah. We're passing. We're calling this, right, as a helper, right, and then as an at test, and it's iterating over that interaction. Once we have that, once we have what we're going to expect, right, that it's we're iterating over these whole interactions, and we're going to expect the inputs to all read correctly, plus 3, 4, plus 5, 12, plus 5, 7, and that the outputs are going to be actually 7. They're actually going to be 12. We concatenate all that into the resulting strings into these string buffers. We can then now feed these fake inputs into the controller, right, as the actual input, as the input into the controller, and the controller runs the model, right, uses the model as an argument, uses the model to parse and act on that input, the 3, the 4, the 5, the 7, whatnot. The output is going to be written into an actual string buffer. So it's going to append 7, 12. We're going to append those values. And now we can compare, right? We can compare what we expected, that plus 3, 4 is equal to 7, and plus 5, 12, 7 is equal to 12, and whatnot, right? And compare that with the concatenated results of the controller actually acting on that input string of events, of interactions, right? So now we're comparing strings to strings, and we know, right, that when we caught the bad controller, right, that there was no munging, there was no misinterpretation of the input. They're being concatenated, right? That these are the actual values that we passed in, right? And then we can assert, it says, okay, this is a string that we were expecting, right? Is that the same string that the actual controller calculated, right? So this allows us to verify both things, right? We can verify that indeed the model is indeed adding correctly, so it's validating the algorithm, but also, right, it's validating that the values that we passed in, made it through all the way to the model without having been somehow misinterpreted or mistransformed or anything like that, right? Which were the two issues that we looked at yesterday, right? That the first one was, is the model correctly running the algorithm, and the second one is the controller inadvertently modifying that that input. This is a little bit, somewhat a little bit too high level, but just wanted to point to this example interaction of how to represent a dialogue.